and welcome to this SDC Verifier webinar. Today we are going to speak about how to design, how to verify the design of your offshore structure with SDC Verifier software. We're going to speak about a couple of popular industry rules. I see that a lot of people at this session today are new to SDC Verifier, so we're going to have a short introduction to the software, but let's start from personal introductions. My name is Oleg Ishchuk. I am in charge of operations here at SDC Verifier. Work for a company for more than 10 years, focusing on structural engineering, FEA analysis, and verification according to rules and regulations. I'm joined here today by Petronek, who is our co-host. He is in charge of our marketing team. So he will make sure that everything runs smooth. If the sound or video is not good enough, he'll let me know. He will also be in charge of your questions today. So if you have any questions regarding what's shown on the screen, feel free to send them to Q&A box or to the chat or to host and co-host and so on. And we're going to have time in the end for the questions. So this session is scheduled for an hour at maximum. I assume that my presentation will take about 30 to 40 minutes, depending on how deep we will get inside of the interface. And then we'll have some time for questions. But I intend not to exceed the limit of 1 hour for sure. Okay, so let's start with the agenda. So what are we going to speak about today? Since, as I mentioned, a lot of people here are new to the software, we are going to speak about the software itself. What is it capable of and what is the workflow? And then we're going to follow that workflow. I'll show you the updated new design interface of SDC Verifier in 2023. I received a lot of positive feedback on that, but also I see that not everybody have upgraded to the latest version yet. So you're welcome to download the newest SDC Verifier from our website. We'll speak about how to start the project, how to work, how to begin the work with SDC Verifier, and we will follow the complete workflow. We'll speak about the loadings and scenarios, conditions, combinations. I'll show how the structural members are detected automatically out of your finite element model. I'll show you a couple of checks, including one of the newest standards in SDC Verifier. We'll quickly get into the optimization of the design based on the requirements of the checks, and I'll show some ways to document the results and present the results. So, but first things first, what is SDC Verifier? SDC Verifier is an extension to popular FEA programs like Ansys, VMAP, and SimCenter 3D. And also, it's going to be, well, it's not public yet, but since you're the first one who joined this webinar, I would like to inform you that we are working on the standalone version, which will work independently, but will be able to import all possible data and FEA models or geometry files to post-process with the powerful solver and own graphical interface. So the development of the software goes in the direction of also having an independent version, but all the things I'm going to show today are applicable for all three FEA softwares and independent. And also we are continuing to develop all the extensions in the same way. So everything which is done in SDC Verifier or will be done in next versions of SDC Verifier will always be available for all three FEA softwares and maybe more, and will also work independently. So we start with simulation. We start with your FEA model. So at the very beginning, you still have to design and build your computational model of your structure with the FEA. Today I'm going to show some example in FEMAP, but again, it can be Ansys, SimCenter 3D, whatever tool you use for the FEA design. But FEA is FEA is an extremely powerful tool, and it allows you to get great simulation results and understand how your structure works, how it behaves under certain loading and with certain boundary conditions. But FEA itself does not answer the question if the structure is okay or not. So you have to follow the rules and regulations. For offshore industry, it is a must. It is a necessity to comply with the regulations of certification or governing bodies for certification or governing bodies. So you have to, your FEA model, your design has to comply with rules and regulations. And this is what SDC Verifier brings into the workflow of the engineers. And we do all the necessary pre and post-processing actions to perform these checks according to rules and regulations. So at the very first step, we do load combinations. Standards are prescribing the loads to be combined in a certain way. So we enable possibility to take into account any kind of loading conditions and combine them together. It is not only helpful to check your model in multiple conditions, but it is also extremely helpful for saving computational time. You can apply only basic loads and solve only basic loads with your FEA program, and then multiply it with the coefficients and build a matrix of loading conditions with SDC Verifier. It is not a must, but it is very helpful and very and a big time saver. But I know that some companies are using different calculation machines. Maybe sometimes design engineers already received a model which is solved. So it is possible to work with your current output sets, with the existing loads, with the existing results, and so on. But load combination is a powerful interface to enhance that. Then the recognition. Recognition is what allows us to make checks according to rules and regulations directly inside of FEA interface, because your FEA model is a huge amount of finite elements. It's thousands or millions of finite elements, but checks are not done on finite elements. Checks are done on structural members like beams, plates, stiffened panels, stiffeners itself, welds, bolted connections, and so on. So your finite element model of a beam member might consist of 50 elements, but we still need to know the effective lengths from connection to connection. We still need to know the force that is going through the complete beam member, or the force in the weld, or stresses in the elements that are subjected to be a weld, and so on. So SDC Verifier has an interface to automatically detect or recognize, as we say, structural members out of your finite elements. It's done within one click. I'll show some examples today. Then next part, and this is the most important part, I assume, it is checks according to standards. So we have more than 35 different rules and regulations in the interface of SDC Verifier. This database and library is constantly growing. Recently, we have added beam member check according to ISO. We have added a new version of the standard of 2020. We are now working on implementing VDI bolt checks. We are now working on AISC 360 of version 2022, if I'm correct. So multiple codes are in progress. Multiple codes are already in the library, but moreover, it is not anyhow limited, because you can also add your own codes. So it is possible to write the checks to the library of SDC Verifier, store them. I know a lot of users do that for some custom routines and custom checks and their own rules. Also, it's possible to modify the existing ones. So the functionality of that is fairly unlimited. Then the last, or almost last but not least is automatic documentation. SDC Verifier allows you to build a calculation report based on the data received from FEA simulation, based on the FEA results, based on the also showing the description of your model, how it's built, how the loads are combined, what are the boundary conditions. So basically allows you to show what was done, what are the results, and does it comply with requirements of the check, and it is completely automatic. And the huge benefit, which I assume is very underestimated, is that it's not just the possibility to build a report. The biggest benefit comes when you need to update the report, because yeah, everybody's used to do a reporting in a certain way, maybe saving some pictures, doing screenshots, putting that into a document or a presentation and so on. But let's be honest, our design is not perfect from first iteration in most of cases. So very often we have to update it. And in this case, we have to go back to the simulation model, change the loads, update the model, recalculate, do whatever else you need to improve the design. And all the other steps are stored with SDC Verifier. So you go directly to the document again. So it is possible to build a multiple reports in a very quick and convenient way of different design iterations, of different updates, modifications, or last minute design changes in a matter of minutes and literally 4 clicks. And then for sure, last thing on this slide is optimization based on requirements of the standards. I was recently presenting a paper on this optimization at NAFEM's World Congress in Tampa. It was actually last week. I received a lot of positive feedback, and optimization shouldn't always be based on stresses. It's important that your structure also has to comply with the requirements, and optimizing the design on these requirements is crucial. So that's the idea of SDC Verifier software. Now let's go to, well, a couple of more slides, and then to the interface and what I was planning to show to you today. So first of all, checks. Multiple checks, as I mentioned, are available in the library of SDC Verifier, but it's not limited. You might see some of the standards we have in the library so far. It's not all of them, because they probably didn't fit on this slide. But as I said, it's not limited. You can write your own. We are constantly adding new codes, and even more important, if you have to follow some rules and you don't see them in the library of SDC Verifier, please let me know, because the priorities of our development depend on the requirements of the customers. Summing up, what is SDC Verifier? Well, we discussed what is SDC Verifier, but what are the benefits of using SDC Verifier? It has code checks directly in your FEA programs, loads and combinations for multiple scenarios are available, and you can report and document the result based on these loads. Automatic detection of structural members is saving a ton of time. Multiple popular standards are available. Let's say like this. Standards can be customized. They're open. You can write your own. Complete calculation procedure is stored. We can do reporting and optimization. But also I want to highlight that we have an excellent support team. Those who use that, I think, can confirm our customers are very happy with our support. We are replying within a day to the emails. Well, at the same day we receive a request. If it requires a bit more of attention, we always inform the customer of the progress of their request. So we recently hired another support engineer. I'm super happy with more people joining our team, and but the most important, and this is something I also heard recently a lot of times, that this is the software that is created by engineers for the engineers. So we know the problems of those who are doing FEA analysis and have to comply with the requirements of the standards. We face it ourselves in our consultancy services. So we are improving and developing to tackle those problems and improve the improve the life of the design engineers. Okay, few more slides. First of all, who are our customers so far? We have more than 100 customers, big companies on all continents using SDC Verifier software. This slide showcases some of them, not only engineering firms or manufacturers of the equipment or those who own the equipment use our software, but also certification societies like Bureau Veritas are using SDC Verifier. We are focused on multiple industries, and energy industry is one of them. So today we are going to speak about some offshore structures. Nice feedbacks from our customers is always appreciated. So yeah, I think important phrase to highlight on this slide is that it's a huge time saver, and everybody understands that. For those who are not users of SDC Verifier so far, I would like to remind that it is possible to try the software. Just download it, go to the license manager and request your trial license, and we're happy to support you during your trial. We are also happy to provide all kinds of trainings, information, deliver the explanations, how-to videos, showcasing what is possible with SDC Verifier and how to perform that. So a lot of information are available in our social media and website. So feel free to subscribe to our social media, search our website for more information, and don't hesitate to contact me in case of any questions by phone or email. Well, you know how to find me. Now let's go to the interface of SDC Verifier software itself. Today we are going to speak about a fairly simple model. Let's not spoil the results, and let's show everything. So once again, I'm going to present to you today in the SDC Verifier for FEMAP, but it's also possible to use the software for Ansys, for SimCenter 3D, and as I mentioned, we are working on the on the independent version. So we are having here a model which represents kind of a basic design of the offshore MudMed. MudMed is an important structure for the industry and for the oil and gas industry processes. It ensures the safety, and it ensures the safe operations of multiple equipment which is installed on it. It also has to work in multiple loading conditions, and that's something we are going to indicate today. With this model in FEMAP, I'm going to use SDC Verifier in a standalone mode. Once again, it's the thing that I prefer to work with, but it is always possible to use SDC Verifier in embed. You can go to embed and you will basically receive SDC Verifier like this in the corner of your FEA program window. So what I wanted to show to you today is the new design. For those who haven't seen that so far, in 2023, we have updated the main window design a bit. Well, I would say significantly. I like this much more. So we introduced the ribbon on top to simplify the view.
Sorry for interruption, yes, but we are still looking at your presentation. You probably shared your window instead of screen.
Okay, this is, yeah, thanks for the comment. Give me a second, I'll stop sharing the screen and share it once again. Share. How about now?
Yeah, now we see.
Yeah, it's good.
Yeah, thank you. Thanks, guys. Yeah, I was speaking for a minute on top of the theme up window and highlighting the model for you. This is what you should have seen for the last minute or so. And on top of this, as I said, we are using SDC Verifier in the embed mode. I prefer to use it on a separate screen, but you can always go, in a standalone mode, but you can also go to embed mode and have something like this when SDC Verifier is on the side of your FEA program design. So as I mentioned, we redesigned the interface. We added some, we introduced the ribbon on top of the SDC Verifier window to simplify and clear the look a bit, and also to put all the functions under the some separate tabs on the ribbon. So all the important stuff about creating a project and opening a project is over here. Analyzing the model and tools are on the home tab. Settings for all the settings, recognition to define the structural members. Tools, all the tools are also in a separate tab. You can call the standards any of the checks of SDC Verifier now from this convenient tab over here. And you can create custom. Help, all the materials about the software and about the license are located in this area. So let's go over the process. I highlighted the process of SDC Verifier at the beginning. So first of all, we have to connect SDC Verifier to your FEA model. So this is already done in my case. When you are starting SDC Verifier for FEMAP, it is fairly easy. You just double click on the icon and you select a model you want to work with. You can also create a new project or open a project as template and so on. If it is done, so that's the workflow for FEMAP and SimCenter. In Ansys, it's even easier because it's introduced to the workbench. So you just drag it from the toolbox in the workbench and connect to your FEA model. Let's go to the next step, which is the loads and combinations. So as I mentioned, SDC Verifier load combinations allows to simulate multiple different scenarios for the model. So in our model in FEMAP, we have basically 9 cases. Acceleration in 3 directions. Basically, gravity was unnecessary for this model because it's also acceleration in that direction. So we could have also skipped that. We have some forces that are operational conditions, let's say, of our structure, and we have some winds. Basically, this structure most of the time it spends subsea under the water, but yeah, somehow we also have wind for this model for transportation conditions, I assume. So first of all, let's show in SDC Verifier what do we have when we connect the model to FEMAP. We have read all the information about the model, like materials that are there, properties of the elements, finite element load, constraint, and so on. And the next thing we can have here is jobs. So from where we solve the model and where we combine the loads. So as you see, we have 9 individual conditions, which we combined in 28 load sets. The structure works for multiple conditions. As I mentioned, we have transportation case when it's delivered to the site. We have installation and retrieval. We have operational conditions. We have some exceptional cases like test or collisions or impacts and so on. So SDC Verifier allows you to build a matrix of loading. This is something we have for this specific case. Well, in transportation, it's fairly easy. Our structure is located on the deck of the barge, and it is subjected to multiple different accelerations. So we have our 3 accelerations in 3 directions, and we just put the factors of those accelerations to our model, which is odd. I think here it was supposed to be the dot on this factor because we applied the unit load on the in FEMAP. So we have x, y, and z acceleration of 1 meter per square second, and then we just multiply it with the different factors. but I'm pretty sure that this result won't be very representative, since it has to be the dots. And I think when it was exported from Excel, in this case, we have comma in some cases, and that comma was not read well. So this is also one of the options. What you can do, I'll show you very quickly over here. So first of all, I have to modify our cases, right? So I'll do replace, and I will replace the comma with the dot in the text. Press next. Replace all. Yes, all the replacements are done now. And when I want to modify the factor, I just copy that from Excel and I paste it over here. Yeah, and everything is now correct. You can import and export to Excel this data. You can modify, you can set factors, add or delete from here, and so on. So we have 16 load combinations of transportation in our model. And we also have some operational cases when we have a gravity and when we have the forces working on our structure. It's combined with the wind. Usually the structure in the operational condition is not subjected to the wind, but this is to demonstrate the variety of loads that can be applied. And then this 28 loading combinations are combined into 5 different loading groups. So we have, so load set is sum of all the actions. So it's basically a linear summation of outputs of everything what's included in it. So if you have transportation 1, you have these 3 accelerations with these factors. If you have operational case, you have these factors, and so on. And load groups are the envelopes of everything what's included in it. So it will highlight for you the maximum or absolute value, so the ultimate result of everything what is included. So in transportation, we have all the transportation combinations. We have multiple combinations for operations, and also we have a load group operation all, which is created from other load groups. So the load groups are not only done from load combinations, load sets. You can also do a load group from individual loads, from load sets, as was mentioned, and from the group of groups, which is very convenient to to summarize some overall to have some overall picture. So when we have combined our loads according to the working conditions of the structure or according to standards, we have to detect the structural members of this loads. So we do have a model that is built with beams and plates elements, and what we want to have for this model is do the checks according to AISC, API, ISO, Eurocodes, and so on. So for that, we have to do the recognitions. I already did that, so I'll just indicate to you the interfaces. First of all, we have a beam member finder, and everything you have to do to detect the beam members in your model is click one button, find, and then the list like this appears. The recognition, this model is 50,000 elements. It was literally 2 seconds to define the members and to recognize all of them. Recognition of beam members is instant. And software, after the recognition is done, treats your model like this. We know all the members in different directions for Y, Z, and torsional, and we can plot them. Let's plot them with member IDs. Yeah, so after the plotting is done, we have a picture like this, where every member and sub-member are shown on the model. So we have plotted the lengths in Y direction. We can also do the same for lengths in Z, torsional. We can edit the members by nodes, or we can filter them. Let's say we want to check if we have elements that are longer than 3 meters. We can filter and find them, and so on. Next recognition is recognition of panels. This structure is also subjected to plate buckling because it has these big panels at the bottom of the mat itself. So when we go back to SDC Verifier and we go to the panel finder, we have the same thing of the recognition of all the sections on the model, all the panels, plates, and stiffeners. So I can highlight for you one of the sections in X direction, for example. Find all the plates on this section, select them and plot them with, let's say, let's do IDs as well. When the plotting is done, we will see a picture of all the plates. This is pretty small section, but we do have some minor plates here. Maybe it's better to select the top one, which is in Z-axis. And this is going to be the outmost top of them. Well, let's select this one, probably. And plot this with labels of IDs. I assume that's again might be not the correct one. So we will do the Z19 just to show you the recognition of plate fields. Yeah, this is a nice example. So all the plates of the top floor of the mat itself are recognized. You have their IDs here. Everything is editable. So if you think you made a mistake and it shouldn't be 1.1 meter, but just 1, you can modify that manually. It will have a small asterisk that modification was done manually and well, notify the others that this modification was done here. So that's how the members of panels, plates, and stiffeners were defined automatically. In the same way, all the welds on the model are recognized. So we will just preview them with highlighting. Yeah, I will remove this text. So all the elements that are subjected to be the weld for weld strengths or fatigue checks are automatically detected. So you can run the checks on them. You can also modify them. You can define the parameters of the weld, so the type of the weld, what is the type of the weld for weld strength check. You can also define the reference points formula for the hotspot stresses and use the hotspot stress method for evaluation of fatigue. So weld finder is not only defining the welds, it's also reorienting the stresses into the weld direction. It's also allowing you to define the types of welds or define the parameters of the hotspot stress. But also when recognizing the welds, we are checking the quality of the mesh, and if there is mesh disconnectivity or so, SDC Verifier will notify you. And this recognition takes about a minute for 1 million of finite element. So model was 50,000, it's a matter of 5 seconds, even less. For 1 million elements on my computer, it took about a minute for doing this recognition. So compared to manual detection, manual definition of the welds, it's basically instant. So after the checks, after the recognition is done on our model, we go to the next part of our workflow. If you still remember the slide, we combine the loads, we did the recognition, and the next step would be the checks. I already have a lot of standards defined in this model, but the one I wanted to highlight to you today is ISO 19902, one of the checks we recently added to the library. For the B members, it is basically a check of axial stresses, bending, and torsion in the B members, but it is only for the tubular members. And in our model, we do have both tubular members and I-beams on top of the mat itself. So we have a very convenient option here in the settings of ISO standard to use AISC check for non-tubular members. When you are creating a new standard, what you do in this way. So let's go to standard step, let's go to ISO and select newest version. You have a checkbox here to include AISC for all the non-tubular members, because as you see for the selection, it only has circular tubes and pipes. And when we define the standard, also one of the new features I want to highlight, you have to set some of the define some of the parameters. All of them are having the description. I'm not going to stop on this today, not to waste the time, but if you click F1 on this window, you will receive a help with the description of each and every parameter. And we recently, well, in the previous version, we added a button to define the standard settings from the library. So now in the settings library, you have a chance to define the settings for all the standards and to use them as default. So if you just go to as I just did, to settings and standard settings in SDC Verifier, you can find ISO code and you can define the parameters for the checks, which are going to be used by default. So after I have created ISO with AISC, the combined check is automatically created in SDC Verifier. This is something which is done predefined in our library, but this is also something you can do for your future check. You can do a check of checks if you want to present multiple different results. So it's fairly simple. If I click on edit, it is reading the result parameters from standards that has been created before from the codes that has been done for ISO and AISC standard. After we did this check, all we have to do to present the results is call a plot. I already did some of them, but you just execute a right click and select how do you want to see your results, with a plot or with the table. We have multiple different types of tables available for the presentation of results. And after that, I'm just doing a double click on the plot, and SDC Verifier highlights for me the results of the check for both AISC 360 and ISO 19902. And we see with the utilization factor that our structure is not passing the requirements of the standard. We have a couple of members. All the pipes are okay, but couple of this box members are not good enough. So what we have to do, we have to change the design, and we have to go to properties. It is probably one of these boxes, beam square of 150, which has to be changed or replaced. And you can do that by just going to FEMAP, adjusting the property and changing the shape, but just guessing the right result. So 150 is not enough. You probably start writing bigger values here and then recalculating the model and recalculating the check. With SDC Verifier optimization, it is much faster. I have a couple of rules created here already. I'll show you one of them. Optimization allows you to check the results of the standard with the multiple different design rules. We do have, well, let's click on this. We do have a possibility to define a rule for beam members, for plate buckling, for welds, for stresses, and for weld strengths and fatigue. And I have already created one rule, which is, I will modify it now to show you, which is based on the operations all load group. On the combined check, well, it is done on AISC because I know that's a box member which is calculated by AISC on the overall utilization factor parameters, and I want my structure to fall under the limits of the standard, so to be between 0 and 1 in the matter of values for utilization factor. What we want to do also, we want to achieve that with as small, well, we want to use as little material as possible. So we want to use as small minimum value of cross-section area. And then you define the variables. So what I did here, I defined the 16 elements, probably some of this at the bottom here, which are not passing the requirements of the standard. and I replaced them with the possible box shapes to replace. How did I do that? You click on this add button and you select, first of all, you select the elements that you want to optimize. It might be defined by the property if you want to change the complete property, like the complete property 17. It is possible, so you select the property from list and define property 17. But if you think it's a local problem and you just have to add to change the cross section for a certain part or a member, you can select either a member from the rules, so beam members, or you can just even add elements manually from your FEA program. So you can click on that, define a group of elements that you want to change. I'm not going to click on all of them now. Pick, and we have some elements that are going to be updated. Then you have to change the to add possible replacements. So we go to our shape library over here and we say, okay, I have in our shape library there is 7,000 shapes possible, but we know that our existing cross section is rectangular tube, so we want to keep to stay with something like that. So we sort our library by rectangular tubes, which is over here. Apply. And then we want the width of our rectangular tube also to fall under certain limits. So we want it to be more than 150. No, it's 0.15. We are in meters here. So we have multiple different shapes. We can select from, well, we have 170 possible boxes to replace. We can select them all. Computational time will depend on, so we can select all and just with the space button define all of them, but computational time depends on the check you do, on the amount of elements you replace, and the amount of possible variables you defined. So we can just select few of them, which I already did. So this is the way how you define, and I defined 16 elements to replace with this 5 possible replacements. And when it's done, you press on calculate, and software evaluates what's going to be the utilization factor, maximum utilization factor for those 16 elements for all of the possible replacements. And then here at the bottom, you can either plot the result, or you can look on the list of results for all shapes or only optimal. I will click on all the cross sections. So in original model, our utilization factor is 1.78, and with the replacement of all of these shapes, we are falling under we are way below the maximum of utilization factor. So we have a possibility to use, well, I should have used maybe something even with a smaller cross section, because 0.43 is really low. So you can go back to edit, adjust your design and so on. But the most impactful thing I wanted to show to you today, that we are not only defining what is going to be the result for the AISC check in this way, but we can also change the model. So we can also click on this button. It will ask us, do we really want to change the model in VMAP? We click on yes, and SDC Verifier is creating a new property in VMAP. So optimization of 16 elements, yeah, this is pretty odd. This is way bigger than I expected. But optimization of 16 elements is done, and mesh is automatically changed. So as you can see, these elements are automatically replaced with the new property. What I have to do now is press OK, go back to home, update the model, analyze it, and generate a report with the results of my design falling under. Well, this is probably not the best idea. I could have done a slightly smaller shape, but this is something that nicely indicates the workflow. And then the last is the presentation of results. So we go to reports tab, we select possibility to add the report. It can be either a wizard, where you do that by checkboxes and simple rules, or a designer where you have a full control over the interface of the software, or a presentation. So to build a PowerPoint slides, we will select an, let's say, full report designer. And when it's done, SDC Verifier launches the report designer tool, which has the complete structure already built. For the complete model, the description is shown, so you can plot every property on your model. For example, the new one we just created. If I click generate on this page, we will say we will generate a slide for this new model. Just a second. Yeah. The parameter is, the property is called optimization because it was done by the it's not the one I have just added because I didn't click on update. Okay, that's one of the previous rules I showcased. But the idea is like this: you show how your model is designed for all the plates, all the parameters, all the properties, loads, conditions, and so on. And then you show the results for your job. For every individual load, you can indicate the stresses, forces, and displacements with plots and tables. And in the same way, you can include the results of standards. So if I go to result, check plots of my combined result by AISC and ISO, I want to create a plot. You define the parameters for plots and include them in your report. I will build a nice, I will generate this report after the session, not to waste time for questions. I will generate this report and we will include that together with the recording to the email we're going to send to you after this session. And for now, this is everything I wanted to show to you today. We very briefly went through the explanation of the software and through every step of the workflow. We showcased the offshore MudMat model. We did the check according to AISC and ISO standards for the beam structure, but also the same can be done for plate buckling, weld strengths, joints, connections, and multiple other checks that are available in SDC Verifier library. And for now, that's everything I wanted to present. Petro, was there any questions in the chat box or in the Q&A box?
Yeah, I see two questions. Maybe later someone also want to add a new one. But for me now is first question is, does SDC Verifier require specific modeling techniques or types of elements for recognition?
Okay. The short answer is no. You can model in the way you are used to, but there are certain limitations. Well, we are following the simple logic and we do beam checks on beams. We do plate buckling on plates. We do weld recognition is done automatically on shell elements, but can also be done on solids manually adding the welds. So you have the interface to add the weld lines. So in general, there is no limitation. We can post-process all the results of different type of elements from your FEA program. But I always like to say that if the problem is simple enough to do it with beams, please model with beams. There is no reason to overcomplicate your model. If you have to do more details, do shell modeling. And if the problem is even more complicated, you're beyond the yielding limit and you want to do something non-linear and you want to do really detailed results and with a good quality mesh, because solids are kind of dangerous for the FEA. If you just mesh everything with pyramids, it's not going to be very well calculated and accurate result. So I suggest, quick answer is no, there is no limitations. We can work with all types of elements, but we follow the simple logic of doing the checks on the types of elements that they are subjected to. And yeah, I think that answers the question.
Another question is regarding custom standards. How to create custom standards and what can be edited in it?
Okay, this is a nice question. As you can see here in the list, most of the standards that we have created are green. These are the codes from our library, which are created, which are stored in our library and which are checked. We triple check the code before publishing it, and which are trusted and proved by numerous calculation reports of our customers. But custom standards are shown in purple. You can convert the existing standard to custom to edit this standard, or you can also convert a new custom standard from here. So you define a name for it. I don't know, you call it my offshore rules. Alias will be standard 16, and you start writing formulas with using the parameters of your FEA model and results. Sorry, this pop-up windows for me somehow appears to the left. So we create custom check, and we can, by clicking plus, we can create formulas from multiple different variables, the result variables, design variables. So it's a simple way of creating formulas, like using, if you know how to write formulas in Excel, you will be able to write formulas in SDC Verifier, even with a more, well, I wouldn't say that the interface is more simple, but it's definitely much more powerful. So yeah, you create either a new standard and it's marked as purple, or you modify the existing one and it's then also converted into purple, as you can see here. Thanks. I also see, Petro, there was some other questions that just popped up.
In the Q&A section, there was a question about version of Ansys, which is required to integrate with SDC Verifier. I already sent a link. We support a wide amount of Ansys from 18.2, but the latest version of Ansys supported only in the latest version of SDC Verifier. But you can use from 19.2.
That is kind of obvious. So yeah, we support all the versions of Ansys from 18.2 and newer, and we are releasing new SDC Verifier after, I think, in about 3 to 5 weeks, let's say in the months after the release of FEA programs, to check if everything works properly within those versions. So the latest version of FEA will always be supported by the latest version of SDC Verifier.
Yeah, and another one, I don't know if I exactly understand the question. Are the results of report generated by SDC Verifier supported by class? Class, I think it's classified communities.
Yeah, this is a most common question. We receive that often. So is that accepted? Yes. We are closely working with all the certification societies. I have visited the American Bureau of Shipping office in Houston a couple of weeks ago. We are working with DNV. We are working and speaking with all the other certification societies. We don't have a stamp automatically or something like that, because it wouldn't be possible to certify the simulation results immediately and instantly, and it wouldn't be possible to support that for as many codes as we have. But our respectful customers, multiple customers around the world, are generating reports and sending them to the certification societies, and they are in general accepted because the report is describing the complete calculation procedure, and everything is open, nothing is hidden in there. We show the procedure, we show the formulas, we show the results, and class societies are well aware of the results that are generated by SDC Verifier, and there is multiple multiple cases of well, all of them are accepted in the end. So thanks for this question. This is very hot
Yeah,
topic and often asked, but this is important to understand.
one more
This is
question
proven
from
thing.
Patrick.
Yes.
Is there a way to visualize SN curves for Eurocode of FKM checks? Maybe in the report.
Visualization, I am not aware of. This is actually a nice idea. You can definitely see the standard tables, and you can, so if we define a Eurocode, and in a quick way, we define all the parameters for that in the FKM. In the input, you have standard tables where you have the SN serve. But is there a way to visualize it? See, sure I understand this interface. If I select everything, click on this. X is row 1, Y is, if we select row 2, you're going to see there. So there is a way to visualize. I wouldn't say it is the standard way of presenting. You have to play a bit with the settings, I think, here, but you can see the standard data table for the SN curve, and you can also create your own custom SN curves, and from here you can also create the graphs. I have to play with this interface myself to understand it better as well, but this is a good question. I think a more standard way of visualization would be also nice, but there is definitely an option to do so. Okay, thanks.
Also questions, is it possible to show detailed calculation done for the checks in the report? As I know, it's
yes,
possible.
it is a very nice question. I actually removed that from my slides not to waste time, but I had a slide like this. So the complete results for every check are available. So basically like a hand calculation, what you can do is to show every formula, intermediate result and intermediate values for a specific member or element, and include that into the report. Yes, it is possible, and it will look like this. You can also export it to the text file or some kind of editor for yourself. Thanks for the question. This is a good one. Okay, we
I
are.
don't see any questions.
Okay, we barely fit into a limit of 1 hour that I suggested. Thank you very much for your question. Thanks a lot for the attention. I hope it was interesting for you. And once again, you know where to find me. Just send an email to oleg@sdcverifier.com or call us, find us on social media, or visit our website. We're happy to provide you with a trial license for the software, and we are happy to work with you in the future. Thanks a lot, and I hope to hear from you again soon.